My name is Krishnan Thiruvengadam, and I'm a technical leader in the technical marketing. So in the enterprise networking, security, policy, and access team. That's a mouthful. Well, 2 years back, and I spoke about Cisco AI Endpoint Analytics in AI Field Day, and we talked about how AI Endpoint Analytics is used to identify and profile endpoints and IoT devices, right? AI Endpoint Analytics sits in DNA Center. It's one of the integral part of the DNA Center. In this discussion, the next half hour, we will talk about how AI endpoint analytics gathers deeper visibility and how you can do endpoint security posture assessment and evaluation, and how admins can take advantage of that and provide trusted access. So the whole concept is called trust analytics, and that's what Scott just said. Okay, so let's take a step back and try and understand what is happening in our workplace and what is the problem we're trying to solve here. Now, as we are coming back to hybrid work, right, and we are seeing employers as well as companies connecting lots of IoT devices as sensors to monitor, and they are concerned about the safety and the security of employees, and they wanted to provide a connected experience, and this gave rise to smart buildings. So these initiatives, what it did was it created a lot of IoT devices, and with already existing plethora of IoT devices in the network, right, the ratio becomes lopsided. The ratio between unmanaged devices and the managed devices become so high. Now, when you have a lot of unmanaged devices, it comes with other sets of baggage, right? These unmanaged devices are agentless. They don't authenticate in a secure fashion. And it is very hard to identify these IoT devices. Now, these IoT devices also have different softwares, and they are unpatched and vulnerable. All of this opens up a lot of threat surface in your workplace, right? And since you're not able to identify it properly, you're not able to segment them properly. So your network becomes porous. And there is a risk where if an IoT device gets infected, the infection crosses across, and there is a lateral movement of infection that could happen in your network. So what do we do? That is the challenge. So the first step for segmentation is visibility. And then once you are able to identify these endpoints, then you could do continuous posture assessment or security posture assessment, as we call it, right? And use that to evaluate these endpoints to provide trusted access. That is what endpoint analytics does. So endpoint analytics provides two functionalities, and one is identify and profile endpoints based on AI ML capabilities and deep packet inspection. The second one is what I spoke about, and this session is about that. And it provides continuous validation of endpoint anomalies, threats, and so on. Okay, so let me give you an overview of what endpoint analytics does before we move on further. Endpoint analytics at its core is a profiling engine. It gathers information from several data sources in the bottom. So the primary data source is deep packet inspection coming from switches and wireless controllers. And we have sensors embedded in Cat9K switches and Catalyst 9800 wireless controllers that provides endpoint metadata that is sent as telemetry data to endpoint analytics. We have identity services engine that gathers plethora of endpoint metadata from other sources, such as MDM servers, MDM standing for Mobile Device Management, Active Directory, AnyConnect, and so on, right? And the third one is easy onboarding tools. By easy onboarding tools, what I mean is that, so if there is a user or a device owner they can register the device in a simple form with a MAC address and maybe an endpoint type with a few other details. And they can also register in bulk. So we have easy onboarding tools. Say in certain cases, in large enterprise, and they do not have, they do not want to register the devices one by one. And they wanted to use something called the configuration management database, where they want all the new set of devices, IoT devices, to be registered there. So endpoint analytics can gather information from that there as well. Now, the idea is that once we gather all the information, we want to be able to nicely profile these endpoints and convert the unknown endpoints that you see to known entities. And we want to be able to identify 90 to 95% of the endpoints like this. Now, what happens to the rest, 5 to 10% of the endpoints? And that's also super important for IT security, right? And we want to take advantage of the AI ML capabilities for that. Now, the way it's done is the endpoint metadata, the attribute values, and it is sent over to the AI ML cloud. And AI ML, what it does is it nicely groups these endpoints based on common set of attributes and behavior and sends this grouping over to the admins. So the admins see a very clean interface, and they see the groupings, and they see that these groupings represent probably a set of coffee machines or a set of thermostats, and they can easily name it, identify it, profile it. Now, once they name it, these labels are also shared with another customer. This is called crowdsourcing. Now, another customer, once they see the same set of endpoints, and they would see the suggestions from endpoint analytics saying that, hey, Mr. Customer, this looks like a coffee machine. This looks like a thermostat. Do you want to accept it or reject it? So based on their choices, the AI ML efficacy improves as well. Now, the data that is shared to the cloud is encrypted. It's obfuscated. And the customer would have their own private key. You can also anonymize data. It's de-identified. The privacy data sheet is available in the internet. So if you Google Cisco DNA Center privacy data sheet, and you will see it. Okay. So the idea is for us to identify endpoints based on device type, model, manufacturer, operating system. So the example being a CT scanner, a hardware model Optima, hardware manufacturer GE, and the operating system is a version of a Linux. Right? So that's the goal of endpoint analytics at its heart. Now, what do we do with that, right? So the overall goal of this is to properly segment the networks. So when endpoint analytics identifies these, and this is what we call multi-factor classification, then it sends this information, it shares this information over to Cisco Identity Services Engine. We've heard about Cisco Identity Services Engine spoken by several speakers here. Right? And at its core, it's a AAA server. So it actually gathers information from DNA Center, and then it pushes access privileges to the network. And the access privileges can be ACLs, VLAN, but most modern way of doing it is using SGT. SGT stands for Security Group Tag or Scalable Group Tags. Right? It is the access entitlement that you get for this particular device, right? Based on this context, based on the multi-factor classification. And at the end, you see something called a trust score, right? At the bottom of this multi-factor classification. So we will talk about that in a bit. Now, the heart of trust analytics is that we want to be able to continuously evaluate the security posture and assess it constantly. Now, we have several sources to take advantage of for evaluating. One of the primary sources from the top, right, clockwise, is secure authentication and posture. Now, we know that ISE or Identity Services Engine can securely authenticate the endpoint using several different ways, right? And it can also assess the posture of the endpoint. Say if you have a mobile device or if you have a laptop, and it can actually look at this posture, it can check for antivirus, anti-spyware, or if the hotfixes are installed or not, and that's called posture from ICE parley, in ICE words. Right? So this information can be gathered if the endpoint is compliant or not. So we use that in creating our trust score. Now, the secure authentication and posture positively influences the trust score. What I mean by that is that the trust score increases if you have secure authentication and posture. There are other factors that negatively influences the trust score. Anything under is negatively influences the trust score. Say, for example, if you have an impersonation attack or if you have a weak software interface on your IoT device, it negatively influences the trust score. So the composition of all of this is what we call a trust score. Trust score stands for trustworthiness of the endpoint. The higher the trust score, the higher the trustworthiness. The lower the trust score, the lower the trustworthiness. Now we will look at the demo for impersonation attack and weak software interface, and I'll explain more about what that does during the demo. We are also looking at endpoints that are trying to access a bad reputation website. Say, for example, if a website is hosting spam, or if a website is hosting a malware, and we have integration with Talos, and Talos is a Cisco threat intelligence engine. It gathers tons and tons of data from different sources, and it processes this data. It identifies different threats, and we want to be we have integration going on with that, and this is currently under EFT. So the idea is that if an endpoint talks to something bad, we'll be able to highlight that and alert the admin. And we will also look at vulnerability and threat metrics in future.
So depending on what industry you're working in, there's complete networks of IoT devices that are air-gapped from the internet and from the cloud. Do you have solutions for analyzing, like performing AI and ML on that traffic to get its to do behavior analysis? If they can't access the central, cloud services that normally do this.
Great question. So for air gap, if you have an air gap network, so you would be losing the AI ML capability, and we are exploring ways of bringing it in, right? However, you would not be losing core functionality. Say, for example, the profiling would still work, right? Because we are gathering information from different sources, from the network itself, right? And from a whole different, from a whole suite of applications and from the network. So you wouldn't be losing a lot of core functionality. You would be good there. The only aspect is the AI ML aspect, where you can identify using grouping, right? And that part of it you would not be able to do. And we are also exploring ways and means of doing it offline. Okay.
Do you see it as still viable then for those air-gap networks? With, like you said, you're still not losing lots of functionality. A lot of functionality is still there, but is it still viable? Does the price change because I have a network that can access the AI ML functions?
As of now, we don't have a solution for that. I think we have that problem to be solved. Any other questions? Okay. Okay, so let's talk about impersonation attack. So what is an impersonation attack, right? An impersonation attack can be due to MAC spoofing or attribute spoofing. So what happens here is that a legitimate device, and say, for example, an IP phone or a printer that gets connected to the network and using a MAC address. Now ICE profiles this endpoint nicely, and the idea is that the IP phone gains a certain level of privileges in the network. Now, a bad guy, a bad actor comes in, and he uses the same MAC address to connect. Then they wanted to gain the same level of access. So that is the idea behind MAC spoofing. In the case of attribute spoofing, right, instead of using the MAC address or on top of using the MAC address, and they wanted to use an attribute value, and this could be certain protocols such as DHCP. DHCP stands for Discovery Host Control Protocol, and this is typically used for getting the IP address dynamically from environment, right? So DHCP has something called DHCP class identifier, and they use this to spoof and gain the same level of privileges. Now, in this demo, we will focus mainly on the MAC spoofing, and we will show capabilities that identifies the MAC spoofing attempt. Okay, so the goal is for us to identify and mitigate against MAC spoofing impersonation attacks. So that is the goal, right? Now, this is the endpoint analytics screen, the first screen that you see in endpoint analytics. To the left, you will see the total number of endpoints. You will see endpoints that are fully profiled, which means that, and I spoke about 4 different profile labels. If an endpoint has all these 4 profile labels, then it's called fully profiled. Even if a single label is missing, it's called missing. It goes under missing profiles categorization. And if an endpoint is unknown, you will see that as an unknown. Typically, if a group of endpoints is unknown, you will see the AI proposals and popping up to the right. So you will see one AI proposal. So this is where the AI comes in and it shows the nice grouping, and the admin sees the wizard as well. Okay. In the middle is where you see trust core, right? And you can see that there are 7 endpoints here that has trust core, and this is my test environment, and that's why you have 17 endpoints. Okay, so you see that there are 2 endpoints that has low score, 3 medium, and 2 high. Okay, so let's take an example of an endpoint that has high trust score. Now, it goes to an endpoint inventory page, and you can see the endpoint MAC address, and in the latest version, you will see the IP address as well. And this is slightly older version. And you will see the location, and you will see the authentication method, and so on. So you can see that the authentication method is a very secure authentication method. It's ETLS, right? And you can see the workstation, it's using an MSCHAP version 2. So these are secure authentication method. And the posture is also compliant, and as I spoke about. So the endpoint trust score is very high. So in the case of an IP phone, it's ETLS, and the posture is not compliant. So this has been authenticating continuously for a while, and then that's why the trust score is high. And 10 is the maximum score you can get. Now, this is the start of the trust score level, right? And before the MAC spoofing attempts. Now, you can also see that when you open up the endpoint details page, and you will see the endpoint type, manufacturer, model, operating system, and you will see the authentication status, authorization profile. All of this information we gathered from Cisco ICE. Right? We can also see the scalable group tag, and I talked about SGTs, right? And last seen. And we also have an attributes tab, and if you go to the attributes tab, and you will see all the different protocols and the attributes that we gathered as well. Now, when you go to the trust core, and you can see that there are 2 functionalities that we wanted to enable. One is the AI spoof detection. Other one is the concurrent MAC address detection. I mean, this can be enabled globally or per endpoint level. Now, once we enable it, and we wanted to simulate an attacker. So in this case, and what I'm doing is, and I have a Kali Linux machine that I'm using, and I have connected this Kali Linux in a different switch. I have 2 switches, Edge 1 and Edge 2. And I have changed the MAC address of the Kali Linux machine to that of an IP phone. And that's what I'm showing you here. You can do that simply on a Windows machine as well. Now I wanted to generate some traffic and I wanted to use a certain utility, Nmap utility. You can also do this with YouTube. And I have, if you open up a YouTube channel, and you can see that there is an alert triggered as well. So you need some kind of traffic. Now, what happens here is that once the traffic is triggered, and you can see that AI spoof detection and concurrent MAC address detection with high severity and confidence. It has identified that there's something bad that's happening in the environment, right? Now, let's pause and talk about AI spoof detection. What does it do, right? And how does it identify these kind of anomalies, right? AI spoof detection actually constructs and builds models of different type of devices. And you have IP phones, printers, cameras, and other devices in your environment. It builds models, and then it gathers NetFlow traffic from your environment to build models. So once these models are built, and this is pushed to DNA Center, and this model is compared with an actual traffic coming from the endpoint. So if the model and the traffic correspond to each other, maps to each other, then it will look like a legitimate device. And if it doesn't correspond, so for example, in this case, we see different types of traffic, and we see Kerberos, and we see HTTPS, and we see all types of traffic here, right? And this doesn't look like an IP phone. So it says with 100% severity and confidence, and it says that, like, it's not an IP phone. So I wanted to trigger an alert, right? So we also have another functionality that actually takes advantage of the native sensors and that are embedded in the wired environment, especially the Cat9K switches, right? So you can see that there are two ports, and that says that it's an IP phone, and then the host name is Kali Linux, and you can see that these two are connected to two different edge switches, right? So it gathers the traffic, it actually looks at the hit rate of this traffic, and then identifies this as an alert. Now, once this alert is identified, and an admin has to take action. So how does an admin take action here? Right? So there is something called ANC. ANC stands for Adaptive Network Control, and this is a concept of ICE. So what happens is any third-party software or any software that is outside ICE can ask ICE. ICE stands for Identity Services Engine, and I know that I'm speaking about different acronyms. I want to make sure, like, I spell it out, and ICE stands for Identity Services Engine. Now, ICE has this concept where it lets other third-party software, such as DNA Center or even Stealthwatch or Firewall, to send action to ICE, asking ICE to block that device or to shut down that device or to quarantine that device. And that's what we call ANC. Now, admins can quickly take action by applying the ANC policy. Now, in this case, I'm going to click on the Apply ANC policy, which is just at the right bottom, and I will see the policies that are already created in ICE. Right? This policy is shared with DNA Center. I want to quarantine this endpoint. Once you quarantine this endpoint, the next time the endpoint authenticates, automatically it goes to a quarantine network, or it is segmented properly with the quarantine SGT. So that's the idea. Okay. Now you can see that the endpoint inventory screen updates with different timestamps, the trust core, ANC policy applied, ANC policy itself, and things like that. Let's take a look at Identity Services Engine quickly and see what policy we have used to quarantine this endpoint. Now in ICE, there is something called a policy set, and this is where you define the policy. Now I have created an exception policy like this. So if an endpoint is a low trust device, And if the endpoint analytics trust score is less than 3, right, and if it contains an IP phone, then apply this security tag, which is the quarantine system, right? Once you do this, the next time the endpoint authenticates, it will automatically put in the quarantine network. And you can also include ANC attributes in the condition. So there are different ways of skinning the cat.
If this software identifies an issue, is there a way it can open up a service ticket so other people are aware, not just the people logged into the system?
Right. So we have integration with CMDB right now, but we are able to pull information from CMDB on IoT metadata. But DNAC has a way of looking at the network assurance, right? And then it allows you to open up a service ticket using ITSM and things like that. Okay.
I may have missed this and I apologize, but the policy sets there, are they suggestions, they're AI suggestions, or are these things that administrators can create themselves based on suggestions from scratch? How does that work?
Yeah, so great question. Policy sets have to be created by administrators as of now in Identity Services Engine.
Okay, so the AI suggestions that you mentioned earlier, are those are simply suggestions for now. It's not like you can click a button and it, easily creates like a policy set for you based on the suggestion.
Okay, so I showed two different products, and one is the endpoint analytics, and the AI ML suggestions are built into endpoint analytics. It suggests you what labels the endpoint analytics should have, what labels the endpoints should have, right? And admins can use that suggestions to create labels based on endpoint type, manufacturer, model, operating system. So that's for endpoint visibility. ICE is a policy engine, right? And once endpoints are labeled, this information is sent to ICE, and ICE actually defines the policy based on these labels.
I see. Okay, yeah. So the labels are really what go into it. They're the core of that.
Yes. The next demo, the next challenge is that we want to identify insecure software interface in the endpoint. Now, what I mean by this is endpoints, like for example, cameras or different types of endpoints, and they could have unauthorized open ports, and they could have weak login credentials, and that could be threat vector as well. And we've seen and heard cameras getting infected within 6 minutes of getting access to the internet. And one type of vulnerability is that cameras are known to have weak login credentials. So how are we going to solve this? Now we wanted to use a way to scan these endpoints from the edge. Now Cat9K has a provision, has a way of getting this application installed as a container. So that's called security sensor. So we want to call this application security sensor, and this is actually pushed from DNA center. Okay, so we want to take advantage of the edge to scan these endpoints. So that's the idea. Okay, so there are two pieces to it, and one is the provisioning piece, and the other one is the scanning piece. Now let's talk about the provisioning piece. The provisioning of this is very quick. So you have to download the software from the Catalyst 9K software download site, and then there is a nice wizard in DNA Center, and I will show you in the demo, and then which will walk you through selecting the switch, and then you can push the container as well. Now, once you push the container, and you can see the status being updated in endpoint analytics. Now, the admin needs to create a scan list and what ports they want to scan, what vulnerability, what weak login credentials, and they wanted to scan for. So once they configure that, and this information is getting pushed to the Catalyst 9K switch, and it starts scanning. And you can also set frequency intervals, right? And then once the scanning is complete, and then you will see an alert from the admin saying that port 80 is open, right? Or you are using weak login credentials for SSH and Telnet, and these are the two protocols that we support right now for identifying weak login credentials. Okay, so the goal is for us to identify open ports, unauthorized open ports, weak login credentials. So this is Cisco DNA Center. Now let's go to the provisioning section. I spoke about provisioning. And then let's go to application hosting for switches. And you already see that there is a 1000 ICE application that's been there already. Now, we need to upload the app. So I go to the software download section of Cat9K, and I download the software from there, and I upload it into the DNA Center. It takes a few minutes to upload. Once the upload is complete, you will see the status saying that it is complete, and you will see this nice box saying that this application is ready to install. And once you click on it, it walks you through the install wizard, and you have to select the site, and based on fabric or non-fabric, and you'll have to select the site, and you have to select the switches. Now, you don't have to select every switch, and based on the density of endpoints, and you can select one or two switches in each location. Now, once you complete that, then you have to choose what VLAN and how do you assign the IP address and so on. Right now, I'm using the dynamic way of getting the IP address using DHCP, and it also shows the progress. You can see the progress saying that like it's getting deployed. And once this is complete, this also takes a few minutes, and you can see that it's provisioned already. So this is good. And you can also troubleshoot with that, with this function. Now, once the task is complete, you can go to the Manage App, and you can see that the app status is running, and the switch name is edgedemo.local. And you can start the app, stop app, and do different things. When you click on the switch, and you can see the network interface being created and the IP address also. This needs layer 3 connection to the endpoints. Just remember that. Now, when you go back to Endpoint Analytics, now at this point, right, like the app is installed and it's ready to scan. Now you need the scan configuration. Here is where you create a list of open ports, and there is a default list already available. Now, I have already created a list just for simplicity to scan port 10 through 100 for both TCP and UDP. Now, I'm also creating a scan configuration for weak credentials. Again, I'm creating a list that supports SSH and Telnet, and I type in the username and password. For new users, you have to create a new list here. Now, once this is done, and this starts the app, since it's sitting in the Cat9K, starts scanning. And you will see the scores getting updated immediately. And you see the red dot under unauthorized ports. Now, we can see that this camera has an open port. And you can also see the port name and the protocol. So it looks like this HTTP port is open. So maybe this is expected. In another case, right, I have another system that has both unauthorized port and credential vulnerability. Now you can see that SSH port is open, okay? And then when you go back and look at the credential vulnerability, you see that it is using a weak login credential. This is not good. So I wanted to take some action out of it. Now the way to take action is very similar. It's consistent across all these anomalies or threats.
For the credential detection, is that like a pre-canned list of stuff that you guys are using, or is that some sort of threat intelligence from Talos, or what are you using to put that together?
Okay, so right now that functionality works with two different protocols, SSH and Telnet. Okay, so you have to create an admin has to create a list of credentials, and we also have some default list. So you could either use a default list or have a list that you can download from the internet, and that actually scans for obvious weak credentials. So once you select the policy, you click on apply, and then the endpoint is quarantined. Okay? The next time the endpoint authenticates, this will be quarantined. And you can see the status being updated, and also the trust score. In the trust score section, you can see the policy being applied as well.
Is this all completely independent of the deployment model of the Catalyst switches? Meaning,
Great question.
does it have to be SD access, or can it just be
that's a slide.
non-XD access?
That's a slide I have.
Okay.
Yes. So we support both Cisco as well as third party. It doesn't have to be Fabric. This is Fabric agnostic. So if you have Catalyst 9K switches and 9800 wireless controllers, the sensors are embedded in these things. So we can gather information automatically. This does deep packet inspection. For third party, and if you have legacy devices, legacy network devices, you need to use something called the DNA traffic telemetry appliance, and that actually takes mirroring or spanning traffic, and then it does deep packet inspection. And this is highly scalable appliance, and this can be placed in the distribution layer or core. This supports up to 40,000 endpoints. So we support both Cisco as well as third party. Okay, so we support different deployment scenarios to answer your question. And these are the minimum requirements you have. So we started supporting with DNA Center 212, Cisco ICE, a different version, the Catalyst switches we support in wireless controller. And if you have third party, then you need to use traffic telemetry appliance.